Here is another rational function. I want us to find everything we know about this. I'm going to ask you for this on your test too.
We have to do synthetic division.
You are going to have to do synthetic division to find something, but we're not going to go there just yet. Start with the easy stuff. The easiest guy for you to ever find is the y-intercept. What do you know about every y-intercept? If x is 0, what do I get here?
-2.
No.
2.
I get positive 2, because if x is 0, gone, gone, gone. -4 for -2 is positive 2. For your x-intercept, you have to do what? Set the function equal to 0, but really, we just need to worry about that numerator being equal to 0 because it's one fraction. So if I take x squared minus 3x minus 4 equal to 0, how do I solve that guy? Bless you. This factors as x minus 4x plus 1, which means I get zeros where? 4 and -1. So then what are my x-intercepts?
Wait, you don't get a 0 for the denominator, right?
4, 0.
You can't get a 0 for the denominator because that leads to something else. We have 4, 0, bless you.
Thank you.
Now, you're speaking about the denominator. What do we get from the denominator?
Vertical asymptote.
Your vertical asymptote is what makes the denominator equal 0. If I say what makes this denominator equal 0, you say what?
2.
X equals 2.
X equals 2. Okay. Well, I have a horizontal asymptote here. No. But I will have an oblique asymptote.
Is that how it'll always be?
What do you mean, how will it always be?
Like we won't have a horizontal one, we will have an oblique.
No, because we showed an example earlier where I had x to the third in the numerator, but x in the denominator, and it had no horizontal or oblique asymptote. Now, in order for us to find the oblique asymptote, we have to do this long division or synthetic division. Can I do synthetic division with this guy? Yeah, I can. So to figure that out, just do your synthetic division with 1, -3, -4. You just blaze through this guy, so that's 1. 2 times 1 is 2. That's -1. Times 2 is -2. I end up with -6. What that means to me is that my original function, which is x squared minus 3x minus 4 for x minus 2, this guy is equivalent to what? How do you translate this into an answer?
X minus 1 minus 6 over x minus 2.
That's what my original function really is, if I were to do the division. So what I'm trying to say is that as x gets really, really large, this remainder piece is going to do what? He's going to go away. He's going to become insignificant. So ignore this guy. So your oblique asymptote will take the form of y equals what? Y equals 1? Or how about this guy, y equals x minus 1? Do you all agree that this division gives me x minus 1 minus 6 over x minus 2?
Yes, but where's the thought process after that?
The thought process is we talk about oblique and horizontal asymptotes describing what your graph starts to behave like. So when I start plugging in very large positive or negative values into this expression, this fraction piece, this remainder piece, goes away. He starts getting closer and closer to 0. Do you all agree?
Yes.
So if this guy starts to approach 0 as I'm getting out to positive and negative infinity, that means my function starts to approach something that looks like x minus 1. Do you believe that? You don't see that?
I
Can we
know it's
graph
getting
it?
closer to 0.
I didn't say it's getting closer to 0. Oh, how do I know this guy's getting closer to 0? Plug in the number 10, plug in the number 100, 1,000, 1 million, and so on. And this fraction piece gets smaller and smaller. The
fraction
larger
of a
the
fraction.
denominator, the smaller the number.
Okay, so, okay, I understand that. So why do you just cover that one the other way?
Because my oblique asymptote is not this whole guy. The oblique asymptote is just there to describe what you start to look like. Even though you never ever equal x minus 1, the amount of effect that this guy has becomes weaker and weaker as x gets larger and larger. Do you believe that? So that's why I'm going to ignore him to find my oblique asymptote. I'm not saying he's not there. I'm saying when I'm talking about my asymptote, I'm going to ignore him.
What is it?
So you guys want to see what this looks like?
Yes.
All right. Well, I'm just going to go ahead and put the graph up here. I'm not going to draw this by hand because, well, I don't think I really need to for this. So here's this guy. This is the graph.
But I want to see the problems.
You want to see what?
You can't just throw it on
No, I just did.
me. Ooh.
What did we say the vertical asymptote was?
2.
X equals 2.
Equals 2.
And I said that my oblique asymptote was y equals, what do we say? X minus 1. So x minus 1 would be right here, and it has a slope of 1. It says positive 1? No. Now before I keep graphing this, notice right here in the middle, is my graph close to this asymptote? No. But look, as I get further and further out here to the left and right, what happens? The vertical distance between these guys gets closer and closer and closer. Do y'all agree? Now, if you were doing this on your own, you would have also plotted the points for your x and y intercepts. Your y-intercept we found to be 0, 2. We found the x-intercepts to be negative 1, 0, and 4, 0. Do you all agree?
Okay, so the rest of the points, when we plug them in up there,
You plug them into the original?
and we do the same thing with like the other one, we don't go through the new asymptotes, we do the regular.
Right. If this is your function and you want to find points on this and you're plugging stuff in, you are plotting those points based on the origin.
Okay.
Now, any points you get, and this is what I would do, I would pick points mainly on one side of this
And then
guy.
just copy them.
Right, and look at the symmetry that we have here. If you rotate about the point of intersection for these asymptotes, you get the same points. Look at this guy. This guy is 2 to the right, down 1. Well, if I go 2 to the left and up 1, there's a point.
So those are useful for symmetry, if you want to copy it.
For-
For the t-table to find out these, same thing?
Yeah.
Yeah.
Now look at this this x-intercept. It's to the left 3, down 1. That means if I go to the right 3 and up 1, there's another point. Okay. You see this point right here looks pretty nice. Looks like he's over 1, 2, 3, 4, 5. He's over 6 and up 1, 2, 3, 4, 5. So go back here. Go left 6 and down 1, 2, 3, 4, 5. So you see that symmetry rotated about the intersection of the asymptotes.